Welcome to Math Mini Lessons. My name is Sarah Fuentes, and in today's lesson, we're going to review the key components of algebraic expressions. Before we jump into today's model, we're just going to review some quick vocab from expressions and equations. You're probably going to remember a lot of this, but we want to go through it just to make sure that everyone is absolutely clear. Here we have an algebraic expression. In other words, we have a collection of terms, an operation, and we even have variables and coefficients. In this expression, we have two terms, the 4x and the 3. On the right, the 3, we call this a constant term, meaning it stands alone. It's a number, we know exactly what its value is. And on the left, we have a variable attached to a number, its coefficient. And the way we would actually spread this out, when we see 4x, we know that means I have 4 of a number, 4 times some number. We have no idea what this number is. I just know I have 4 of them. So I can express it in this way if I wanted to have an expanded form. 4x's plus 3. As we got older, we knew that we can take this repeated addition and we can express it as 4 times that number. Repeated addition, we're going to express it as multiplication plus 3. And to make it even more simplified, we literally just put that 4 and that x next to each other to represent that multiplication. So in simplest terms, we get 4x plus 3. Makes a lot of sense, doesn't it? We don't see the operation of multiplication, but we know it's there between the 4 and the x because we know how to translate that term. Let's go into our model now. And our model has to do with combining like terms. And what that means is we want to take our expression and anywhere possible, combine the terms that are the same so that we have fewer terms and our expression is friendlier. So starting with the one here on the left, notice we have 3 sets of terms. 4 times the number. So again, I have 4x's, 6 times the number, and 3. All this is in my expression. And just looking at it in this way, you can tell which things are alike. All these x's are the same, meaning instead of just having them spread out, we can call it x plus x plus x plus x and repeat it 10 times. But let's do it as a faster way and just say we have 10 sets of x. And we can just express that as 10x. And our 3, again, stands alone. I can't get this any simpler. They're just 2 terms. I can't add my 10 and my 3 because, again, we have no idea what this number actually is. So I can't combine and say I have 13 of them because we don't know for sure what the value is of this x. Let's look at our ones on the right. Again, we have 3 terms, 3x plus 5 plus 3y. I'm going to do this one in a different color. So again, 3 x's, a 5, and 3 y's. So when we put this together in our group, there's no way I can simplify this any more than I have it. There's nothing to combine together. I still have 3 x's, I still have 5, and I still have 3 y's. I can't combine my x's and my y's because although there are numbers, they have different values. They absolutely do. If they had the same value, we would have to use the same variable. So this is another way of just envisioning combining like terms, but I want to give us just one more example or situation. What if I had 3x plus 5 minus 2x minus 3. Now I have 4 terms. I want to put the things that are alike next to each other to make it easier. So I'm going to put my x's together, 3x minus 2x. And I'm going to put my constants together, plus 5 and minus 3. This is going to make it easier for us to combine these like terms. So my 3x minus 2x, think of it as I have 3x's And I'm going to take 2 of them away. That's just going to leave me with 1x. And my 5 minus 3, that one also makes sense. I have 5. I take 3 away. I'm just going to have 2. Positive 2. So this is my most simplified version. 1x plus 2. So again, as you're going through practice, anytime you have algebraic expressions, you can combine any terms that are alike, meaning any terms have the same variable, add them together. Pay attention to the coefficient to figure out what that looks like, and also pay attention to if you have positive or negative coefficients. And the same thing with your terms. If you have constant terms, we can also add them together. Even if you have a positive or negative, again, think about your integer rules, but you can also combine all your constant number terms. So that's our lesson for today in Math Marble. We will see you in the next one.